Hello, PreCalculus. I looked through your feedback there on flipping the classroom, and I was actually kind of surprised to hear that an overwhelming majority, like 90% or higher of you, liked flipping the classroom. I had lots of good feedback on ways that I can make it better. One of them is giving more examples. One of them was giving some problems that you could try on your own with some solutions so that you can try out, know what you do know or don't know before you attend class the next day. So I think I'm going to try starting to incorporate those as well. Not that you would have to do the problems or have to turn them in, but for those of you that are inclined to maybe get started a little bit on the problem solving at home, you could do so. Also, we're going to be doing some more problems at the board. Now, this has always been my intention, like as the material gets harder, there's going to be more of us working problems together in the beginning, and then I would set you free. For some of the stuff that we've done in the past, like the domain and range, increasing, decreasing behavior like we're doing today, that should all be a review from Algebra 1 and Algebra 2, so I tend to go a little bit faster with that. Please know that as the material gets harder or becomes new to you guys, I will start slowing down and giving you some examples, but I really like the idea of also giving you some problem sets that you could work on so that you can test whether you actually know it or not before you come to class. If you choose to do, it would also give you a set of problems to work on should you come to class and think you had it and you've asked your questions, you're still struggling. It'll give you some more practice problems to work on at home for those topics that you struggle with. All right, so here is section 1.4.1. Some of you said, I don't like having homework every night. Well, you either have problems, you have videos. And then another concern was they did not like not having the notes printed out for them. Like I said, my goal is to get you guys to handwrite your own notes. I do provide what you see on the board here that you could print out if you want to, but you really should be trying to do it by hand, just like you were in a college lecture, so that you are able to do that when you go to college. I don't want you to be lost and not know what to do when you get to college next year or the year after that. So here we go, increasing or decreasing behavior. So a graph is increasing, or a function is increasing on an interval if and only if for any 2 points in the interval, a positive change in x results in a positive change in y, but we're going to call that f of x, positive change in f of x. All right, that's a lot of words, right? And some of them are kind of fancy. So let's read it again. A function is increasing on an interval if and only if for any 2 points in the interval, a positive change in x results in a positive change in f of x. So all that is saying is as we read our graphs, we always read our graphs left to right like we're reading a book or like we're reading a sentence. So as x is getting bigger, it's increasing if your y is also getting bigger. So this is my increasing example, because as I go left to right on the graph, my pen gets taller or gets higher, right? My y's get higher. All right, so a function then, what do you think it would be for decreasing? A function is decreasing, on an interval if and only if, mathematicians write that as IFF, if and only if, for any 2 points in the interval, let's call that interval I did it the first time, but let's do it this time, a positive change in X results in what? A negative change in f of x. A function is decreasing on an interval I. That's where I wanted to put it. If and only if for any 2 points in the interval I, a positive change in x results in a negative change in x. So a positive change in x would be reading the graph from left to right, just like a book. So as x's are getting bigger, my y should be getting smaller. That's decreasing. All right, and then our third possibility, we're either increasing or we're decreasing or we're what? We're staying the same. So a function is constant on an interval I. You can call your interval whatever you want to, but on an interval I, if and only if for any 2 points in I, which is our interval, so any 2 points in the interval, a positive change in x results in no change in y, or in f of x. So as I go from left to right, this part here is my constant interval. So when I go from left to right and I'm reading, here I am decreasing, and then I stop and I stay the same y. This is the constant interval, and then it drops off again and starts decreasing. So let's look at some graphs and see that in action. So looking at graph A, we want to estimate the intervals to the nearest 0.5 unit on which the function is increasing, decreasing, or constant. Well, if I look at A and I go from left to right, like I'm reading a book, and I go down, 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 so we're decreasing, decreasing, decreasing. It kind of looks like it's going to get flat here, but this is a cubic, right? And cubics really, they are still decreasing the whole time. They've got a point of inflection here, which we're going to talk about in just a second. They're going to go from concave up to concave down, but we are still decreasing, 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 decreasing. So for this cubic function, we are decreasing on its entire domain. So we're decreasing on the x values between negative infinity and infinity. Not very exciting, right? All right, let's look at B. This looks to be an increasing function overall, right? But on this portion here, I'm getting bigger, then I take a turn for the worse and start getting smaller, and then I go back to increasing. So let's find those increasing intervals. Let's see, it's going to start increasing at negative infinity, and that's going to go up to what? Looks like negative 1 to b. It is also increasing over here at positive 1. So from 1 to infinity, it is also increasing. What that means is between those 2 points, between negative 1 and 1, my graph is going down. So let's talk about a couple of different things. First of all, it's increasing the interval we're talking about. If I ask you for an interval, that's always asking for which x values. So my x values are between negative infinity and negative 1. My x values are between 1 and infinity. I'm not asking for y values for an interval. I'm asking for x values. And so this guy is not a point, it's the interval from negative 1 to positive 1. That's where my graph is getting smaller. Also notice that these have parentheses and not brackets. So when I'm right up here at negative 1, I'm neither increasing or decreasing. I'm at what's called a maximum point or an extrema. When I'm there, I'm neither increasing nor decreasing. I'm turning at that point, right? So they don't get included in our intervals for increasing or decreasing. They're not doing either. All right, so go ahead and pause your video here. See if you can find intervals for increasing, decreasing, or constant. All right, hopefully you paused your video. Let's look and see how you did. So for our A here, I'm looking, I see increasing intervals, I see decreasing intervals. All right, so for my increasing interval, if I go left to right, this guy's getting smaller, 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 smaller. So that's not increasing, that's decreasing. So let's go ahead and do that one. So from negative infinity all the way up to this point here is when my graph is getting smaller. So from negative infinity, that looks like 2, positive 2. And that 2, we turn and we go back up. So now we start increasing all the way up. As x goes out to infinity, from 2, we are increasing. So from 2 to infinity, we're increasing. For B, I see an increasing piece and a constant piece. So for increasing, that's from when x is at negative infinity all the way up to this point here. So it's going down to infinity, but we're increasing this whole time, right? So from negative infinity all the way up to negative 3, we are increasing. And then at negative 3, we turn into a constant function. All right, so we're right here, we go from, well, it looks like actually negative 3.1. Nice that they give us the piecewise function there, huh? So at negative 3.1, it looks like it's a little bit further over there. So at negative 3.1, all the way out to infinity, we are going to be constant. This will help you if you have a piecewise function. This one's not as helpful, right? Not a piecewise function. But piecewise functions will give you the nice x values where it changes from one thing to another. And then also I wanted to say, notice I didn't say from negative infinity to 1.7, we're increasing. That would be the y values where we're increasing. But when I talk about increasing, decreasing, or constant, we're talking about intervals. And intervals are always x values. All right, that's it for video 1. Come back, we're going to do video 2. We're going to talk about extrema and maximums and minimums.